Hello everyone, welcome to IRT and GATE classes. This is lecture 6 on operating system, and in this lecture we are going to start a new scheduling algorithm, that is SRTF or SRTN. SRTF means shortest remaining time first. Okay, SRTF is shortest remaining time first. Remaining time first. Okay. And SRTN is shortest remaining time next. Okay, first and next, I think you have got it, one and the same thing. Okay. Yes, so shortest remaining time first or shortest remaining time next, one and the same thing. So we are going to start this CPU scheduling algorithm. Okay, so as we have seen in the previous lecture, we will try to solve a numerical over on it. Okay, you will get more clarity. So the basic task here is we have to design a Gantt chart. If we are able to design a Gantt chart easily, then I think everything is over. Now we just have to find turnaround time, processing time, finish time, and so on. Okay, we can easily calculate all those kinds of things. Okay, so let me show you uh, Gantt chart. Okay, how to make the Gantt chart for it. Okay, so as we have said, shortest remaining time first. Okay, so that you can say that process will be given more priority whose remaining time is less. Okay, we have set a shortest or whose remaining time is shortest. Okay, that will be given more priority. Okay, so let me show you the Gantt chart for it. So see here, arrival time 0 is for P1 only. Okay, so obviously at 0 time, no process is there in the memory except P1. So obviously we have to start P1 first. Okay, so or we can say more precisely, we should say at time 0, no process is in ready state. So only one process P1 is in ready state. So we can easily start it. Okay, yes. So how Gantt chart will look like? Let me show you here. Okay, yes. So first of all, we will start with which process? P1. At time 0, P1 has been started. Now at time 2, P2 is coming. So obviously from 0 to 2, we have no choice. We have to start P1 only. Okay, we have to execute P1 only on the CPU because from 0 to 2, we have no choice. Okay, at 2, at time 2, or you can say at 2 units of time, this unit can be the seconds, nanosecond, whatever may be the case. So at time 2 units, P2 arrives in the system, and when P2 arrives, see the remaining time of P1. Since P1 has been executed from 0 to 2, that means 2 unit of time P1 has been already executed. So remaining time of P1 is nothing but 23. 25 minus 2, that is 23. Now remaining time of P1 is 23 and the remaining time of P2 is 20. So which is less? I have told you, algorithm is shortest remaining time first. Okay, or shortest remaining time next. Now remaining time of P1 is 23, remaining time of P2 is 20, which is less? P2 is less. So P2 will be executed. Now see here carefully, we have started P2. Now till what time I will execute P2? See, at time 3, P3 is coming into the picture, or you can say P3 is coming to the ready state. Okay, so now again, I have to check at time 3, I have to check which are the processes which are available, and which process is having minimum remaining time, that will be executed first, or shortest remaining time, that will be executed first. So obviously P2 will be executed till time 3. Okay, now see here carefully, P1 was executed from 0 to 2. Why it was executed from 0 to 2? That means for 2 seconds why P1 was executed, because at time 2 P2 was coming into the picture. Okay, so we were having a choice. So at time 2, we are having two processes in the system, P1 and P2. P1 remaining time is 23 and P2 remaining time is 20. So which is having less remaining time, that will be executed first. So P2 was given priority and P2 has been started. Now till what time P2 will be executed? Time 3, because at time 3 or time 3 unit, P3 is coming into the picture. So now at time 3, I am having three choices. See here carefully. Now I am having three choices. Okay, now from these three choices, which is having the least remaining time, that will be executed first. So which is having least remaining time? P3 is having least remaining time because see here, P2 has been executed for 1 second, so remaining time of P2 will be 19. P3 remaining time is 15, P2 is 19, P1 is 23, which is having least remaining time, P3. So P3 will be executed first. Okay, P3 will be executed. Till what time P3 will be executed? See, 8 time. Okay, for till 8 time, because at 8 time P4 is coming into the picture. So 8 till 8 it will be executed. So 8 minus 3 is 5. So 5 units P3 has been executed for 5 units. So finally its remaining time will be 10. Okay, so now at time 8, we are at time 8 now. See here carefully, we are at time 8 now. Okay, yes, so we are at time 8 now. Now at time 8, how many choices we are having? We are having, see this, 4 choices we are having. P1, P2, P3, P4. P1 remaining time is 23, P2 remaining time is 19, P3 is 10, and P4 is 5. Which is least among all? P4 is least among all, so P4 will be executed next. Okay. So that is the meaning. Now, meaning is the term itself is saying shortest remaining time first, or you can say shortest remaining time next. Now you have got idea why first and next time I was saying that they are same. Shortest remaining time first means what? From all these, who will be executed first? P4 will be executed first because it is having shortest remaining time. Okay. Or who will be executed next? Because till now we were executing P3 now. So who will be executed next, or after P3 who will be executed? P4, because it is having shortest remaining time. Same scenario. I think you have got it. Shortest remaining time first or shortest remaining time next, one and the same thing only. Okay. So finally P4 will be executed for how much time? See here, for how much time it will be executed? At 10, a new process is coming into the picture. P5 is coming into the picture. So till 10, I will execute P4. So two times, 2 units of time it has been executed. So its remaining time will be 3. Okay. So now at time 10, we are at time 10 now. At time 10, how many processes are there in the scenario? All the 5 are there all the 5 are now present. Okay. So from all these 5s, who will be executed first? Which is having the least remaining time. So P1 remaining time is 23, 19, 10, 3 and 2. So who will be executed? Obviously P5 will be executed. So P5 will be executed now. Okay. For how much time? Its burst time is 2. So obviously it will be completely executed and it will go out of the system. Okay, because it has been executed. P5 is over. That's why I have cut it. So now see which is having least remaining time. P4 is having least remaining time. So P4 will be executed now. For what amount of time? 3 unit it was remaining. So 12 plus 3 is 15. So till 15. So again P4 is over now. So now see P3. P3 will be executed for 10 units of time. P3 will be then over. So 25. Okay. Then P2 will be executed for how much time? 19 unit of time. So 25 plus 19, 44. Okay. So after that, P1 was remaining. So P1 will be executed till 23 time. 23. So 44 plus 23, it will be, I think, 67. Okay. So finally, this is our Gantt chart. Now, once Gantt chart is prepared, everything is over. Okay. You can think everything is over. Now you can easily find turnaround time, waiting time, response time, and all. You can easily find out. Okay, whatever they are asking in GATE exam, you can easily find all these kinds of things. I hope I have made the point clear to everybody. It was really very simple algorithm, okay, and very easy to understand. Now, very important point is coming. Please try to concentrate here. P1 was executed for only 2 units of time, and then CPU was snatched from the P1 and it was given to P2. That means P1 was not executed completely, and still CPU was snatched from P1 and given to P2. So what does this mean? SRTF or SRTN is a preemptive scheduling algorithm. Preemptive scheduling algorithm. Why we are calling it as preemptive scheduling algorithm? Because process has not been executed completely, but still CPU has been snatched from the process and given to other process. Okay, so snatching means preemption. Okay, so P1 has not voluntarily released the CPU. CPU was not released by P1 on its own will. It was against his will. P1 was not ready to give the CPU, but still CPU was snatched from P1 and given to P2. So I hope I have made the point clear. This is a preemptive scheduling algorithm. And if you see carefully, SRTF is nothing but preemptive version of shortest job first. I have told you in the previous classes also, SRTF or SRTN. Let me write it here only. Okay, it is nothing but you can say preemptive version of, okay, preemptive version of SJF. Okay, it's just like SJF only, na? Process having smaller burst time that was executed. Okay, so it is just like SJF only, but the only thing is CPU is preempted in between. In SJF, CPU was not preempted, but here it is preempted. So hence we are calling it as preemptive version of SJF. I hope I have made the point clear to everybody. Okay. So now, just for the sake of formality, you have got everything, I know, but just for the sake of formality, let me show you something. For example, I want to find, say, waiting time of any process, say P1. Okay. I want to find waiting time of P1. Let me show you how to find it. Okay. So it's just for the sake of formality I'm doing. I think you already know all these kinds of things, because once we have prepared the Gantt chart, everything is over. You can easily find waiting time, response time, turnaround time, and all these kinds of things. Okay. So now I want to find waiting time of P1. So what is the waiting time of P1? I think you already know what was the formula. See, you just have to apply the formula. You will get the answer. Waiting time of P1 will be turnaround time minus burst time. Okay, that is the waiting time. So what is the turnaround time of P1? Turnaround time of P1 is, turnaround time was what? Process finish time minus process arrival time. Okay, and then again minus burst time. So process finish time, when P1 is finished, 67. When P1 was arrived, P1 was arrived at 0, minus burst time. Burst time of P1 is 25. Directly you will get the answer. 67 minus 25. It comes out to be, I think 42. Yes, 42 is the answer. So 42 units of time P1 has waited. So if you want to check, I can show you here itself. See, P1 arrived at 0 time. So see from the Gantt chart, P1 arrived at 0 time and it has executed here only. So no waiting. But after 2 and till 44, P1 was not executed. So directly indirectly, P1 was waiting from 2 to 44. So what is the time from 2 to 44? 44 minus 2, that is 42. So 42 units of time P1 has waited. I think I have made the point clear to everyone. Okay, now let me show you something. Say I want to find response time of P4. Okay, let me show you. I want to find response time of P4. I'm just doing questions randomly. Whatever question is coming to my mind, I'm just doing randomly. So response time of P4 will be what? Response time was what? Process start time minus process arrival time. I think you already know the formula. So you just have to apply the formulas. Now nothing is there. Okay, just apply the formula. You will get the answer. Process start time. P4 has started when P4 has started at 12. Okay, P4 has started at 12. Arrival time. P4 arrived at when? P4 arrived at 8. Okay. Oh, sorry for that. Sorry for that. I forgot. P4 started at 8. Na? This was the second time when P4 was executed. P4 was executed here first. So process start time. So P4 has started at 8 and it arrived at 8. So response time will be 0. Start time minus arrival time. 8 minus 8, that is 0. So response time of P4 is 0. Okay, I hope I have made the point clear to everyone. Okay, so and let me show you one more thing, just one more thing. Waiting time of, say, which process we want to find. Say we want to find waiting time of P3. What is the waiting time of P3? So according to the formula, it will be turnaround time minus burst time. So turnaround time of P3 is what? Turnaround time of P3 will be process finish time minus arrival time. Okay, so let me write it here. Yes. Turnaround time will be process finish time minus process arrival time and then minus burst time. Finish time. So when P3 is finished, 25. See here, P3 is finished at 25. Minus arrival time. P3 arrived at 3. Burst time. Burst time of P3 is 15. So 25 minus 3 minus 15. So it comes out to be 22 minus 15. Okay, so what will be the answer? 22 minus 15, it comes out to be 7. 7 is the answer. Now, if you want to check it out, from the Gantt chart, you can easily check it out. Waiting time of P3 is coming to be 7. See this. So P3 arrival time was 3, and at 3 only it has been started. So P3 has started at 3 only. That's why you can easily say response time of P3 is also 0. Okay, let me response time of P3 is 0. Why it is 0? Because at 3 it has arrived and it has started at 3 only. Whenever process has started at 3 and when process arrived at 3 only, so obviously response time will be 0. So it comes at 3 and immediately it has started until 8 has been executed. So there was no waiting at all. And then P4, P5, P4 and so on, they were executed. So finally from 8 till 15, P3 has waited. From 8 till 15, P3 has waited. So what is the waiting time? 15 minus 8, it comes out to be 7. So I have told you 7 only. So I hope I have made the point clear that why waiting time of P3 is 7. Okay, yes. So now please take snapshot or something. Everything I have put on the one slide. Take snapshot. I will jump to the next slide now. Okay, so this was one of the best example which has cleared all your doubts regarding shortest remaining time first or shortest remaining time next. Okay. I'm jumping to next slide now. Okay, so again, I'm showing you one more question on shortest remaining time first algorithm. Okay, so again, this is very simple example. Now see here carefully, arrival time is not given. I have told you many times, if arrival time is not given, you will take arrival time as 0 for all the processes. So now since arrival time is 0, so directly and indirectly I will say all the 4 processes are available at time 0. When all the 4 processes are available, so obviously which process you will start, which is having least remaining time. So remaining time, or you can say burst time, so it is 2. So for P4 will be started first. Okay, I am preparing the Gantt chart. From 0 to 2, P4 will be executed, and then P3 will be executed till 5 because its burst time was 3, and then P2 will be executed till 9, and then P1 will be executed till 14. So this is the Gantt chart. So you will say, sir, why you have solved this question? This was really very, very simple. Here, I just want to clear a very beautiful point. Okay, see here in the previous slide, at time 0, there was no choice. We have to execute P1 because no doubt P1 burst time was really very, very high. But still we have executed P1 because there was no choice at all. Arrival time was 0, so there was no choice. At time 0, we have to start something. So we have started P1 because CPU should not remain idle now. Okay, so we have started P1. Now at time 2, P2 comes into the picture. So at time 2, we were having two choices, P1 and P2. So P2 started and so on. Okay, so after time 10, see this, after 10 time, every process was available. Now see the yellow color which I have shown you. Okay, so after 10, every process was available, and then we have simply applied C, which was having remaining time least, that was executed, and so on. I have told you in the previous slide. So now here every process was available at time 0 only. So I have executed directly. So I think you have got it. This is nothing but your SJF, shortest job first. So you can say when all the processes are present, or you can say when arrival time is missing, then SRTF or SRTN will behave like your SJF. Okay, so let me write it. When all processes are available, when all processes are available at time 0, or arrival time is missing in the question, then your SRTF or SRTN, they will behave same like your SJF. So this question has been asked in GATE, by the way. Okay, so when arrival time is missing or when all processes are present in the system, then SRTF and SJF both will behave same. Yes, this statement is true. Okay, both will behave same. I hope I have made the point clear. Please take snapshot. I will jump to the next slide now. Okay, so I'm jumping now. Yes, so next question is finish time of P1. They want to ask finished. I have written question in the shortcut manner to just to save the time. Finish time of P1 they want to ask, if SRTF is used and process which has not been executed is given priority. You will say, sir, what do you mean by process which has not been executed is given priority and all? What does this mean? So please do not worry about it. You just concentrate on the question. Finish time of P1 has been asked. This is the question. And they are asking SRTF is used. Okay. So let me draw the Gantt chart. Okay. Once I will draw the Gantt chart, everything will be crystal clear to everybody. Okay. So let me draw the Gantt chart. Okay, so initially at time 0, there is only one choice P1. I have no other choice, so I will execute P1 only. Till time 1, I will execute P1 and its remaining time will be 4. At time 1, P2 arrive in the system and its remaining time is 3. Okay, and its remaining time is 4. P1 remaining time is 4, P2 remaining time is 3. Which is less? P2 remaining time is less. So P2 will be executed. Till what time? At time 2, new process is coming into the picture. So at time 2, P2 will be executed. So its remaining time will be 2. Okay, now at time 2, we have 3 choices. Are you getting it? Na? At time 1, at time 0, there was only one choice. There was only one choice at time 1, that was P1 only. So we have executed P1 and and at time 2, sorry, at time 1, at time 0, only one choice, that is P1. At time 1, there was two choices, P1 and P2. These are the two choices, P1 and P2 at time 1. So I have taken that process which is having less remaining time, okay, or least remaining time. So P2 was executed. Now at time 2, I am having 3 choices. See this. At time 3, I am having 3 choices, P1, P2, P3. So which process will be executed, which is having least burst time, so, or least remaining time. So it is having 2, 4 and 1. So 1 is the less. So P3 will be executed next. Till what time? Obviously burst time is 1 only. So at time 3, anyway it is going to be over. So let me cross it. Okay, see my method. What I am doing, I am just making the Gantt chart, and side by side I am cutting the burst time and I am cutting the process also. If you follow this kind of thing, no silly mistake will be done in GATE exam. Otherwise, you will definitely do some kind of silly mistake. You will forgot to add something, you will forgot to subtract something and so on. So you will waste a lot of time in GATE exam. Better is you just do practice like me. Okay. So immediately, whenever you write something here, you immediately cut and cut the burst time, and if process is over, you simply cut it like this. Okay, so P3 is over now. Now at time 3, I am having 3 choices. See this, P3 is already over now. So now I am having 3 choices. Please don't say 4 choices. P3 is over. I have no choice. P3 is over. So now I am having how many choices? 3 choices I am having, P1, P2 and P4. Okay, now see carefully. P4 burst time is 2. P2 remaining time is also 2. P4 remaining time is 4. So now there is a tie. P2 and P4. There is a tie between P2 and P4. Both remaining time is 2 only. So now this statement, now you read this statement, you will get more clarity. Say this, process which has not been executed is given priority. So which process has not been executed? P4 has not been executed. So I will execute P4 first. Okay, so I will execute P4 first. So till what time it will be executed? Obviously 5, because its burst time was 2. It is over now. So now I am remaining with P2 and P1. P2 will be executed till 7. It is over, and then P1 will be executed. Then 7 plus 4, 11 till 11. Okay, so finally our Gantt chart is made. Now what they were asking, finish time of P1. So what is the finish time of P1? Finish time of P1 is 11. So answer is 11. If they ask finish time of P2, finish time of P2 will be 7. So P1 finish time is 11, P2 finish time is 7. Anyhow, now they can ask any kind of question, you can answer. Waiting time of P1, waiting time of P2. Okay, whatever they want, they can ask. Okay, for example, they can ask waiting time of P2. Waiting time of P2. So waiting time of P2 means what? Turnaround, waiting time means what? Turnaround time minus burst time. Turnaround time minus burst time. Okay, so what is the turnaround time? Turnaround time is process finish time minus process arrival time, and then minus burst time. Finish time, when P2 is going to be finished, P2 is going to be finished at 7. So 7 minus arrival time, when P2 arrived in the system at time 1. So 1. Burst time of P2 is 3. So 7 minus 1, that is 6. 6 minus 3, that is 3. 3 is the answer. Waiting time of P2 is 3. If you want to check it out from the Gantt chart, we can easily check it out. Waiting time of P2, we want to check it out now. So see this, at P2, P2 arrived at 1 and it has started at 1 only. Okay, so there was no waiting at all. It has immediately started. Till 2, it has been executed. Now from 2 to 5, it has waited. From 2 to 5, it has waited. So how much time it is? 5 minus 2, that is 3. Okay, so 3 we have shown you. 3 is the waiting. Okay. Yes, so I think I have made the point clear to everybody. Yes, so I have put everything on a one slide. Please take snapshot or something. I will jump to the next slide now. Okay, now I am jumping. So this is GATE 2007 question. They are asking waiting time of P2 using SRTF. So I think you can easily solve it, but let me solve it for you. Okay, so process ID is given, arrival time and bus time is given. So at time 0, there is only one choice, that was P1. So let me draw the Gantt chart first. So P1 will be, obviously when there is no choice, I have to start from P1 only. Now at 15, I am having a new choice. Okay, at time 15, P2 is coming into the picture. So blindly, I will execute from 0 to 15, I will execute P1. So its remaining time is 5. P1 remaining time is 5 because I have executed till 15. So P2 is coming into the picture at 15 and its remaining time is 25 and its remaining time is 5. So which is having least remaining time? P1. So I will execute P1 only. Okay. So I will execute P1 only and it will be executed till what? At 30 new processes coming into the picture. Na? At 30 new processes coming. So I will execute 5 times. Okay. So 5 times, that is 20. So till 20, P1 will be executed and we will cut it out. I will cut it out. Now at 20 time, there is no other process except P2 in the system. So there is only one choice. I have to execute P2 only. Please try to concentrate here. If you have any doubt, please rewind the video and watch it again. I will not repeat it again and again. Okay, so P2 is coming into the picture. Why? Because at after 20 time, P1 is over and at 30 time, P3 is coming into the picture. So obviously at 20, there is only one choice, that is P2. So I have to execute P2. Now till what time I will execute? Till 30. 30 time I will execute because at 30, P3 is coming into the picture. So everywhere at arrival time, we will take a pause and see the Gantt chart. Okay, whatever is we are doing, we will take a pause and see what are the choices and all. Okay, so at 30, I have to pause. I have to see which are the new processes in the system and so on. So 20 till 30. So 10 time. 10 time P2 has been executed. So its remaining time is 15. Okay, and P3 is coming at 30. Na? Yes, so its remaining time is 10. So now at 30, we have two choices. These are the two choices, P2 and P3. So do not say P1. P1 is over. Okay, that's why I have cut it out. Okay, so now 10 and 15, which is having least bus time, P3 is having least bus time. So P3 will be executed, or P3 is having least remaining time. So P3 will be executed. Okay, now till what time? So at 45, P4 is coming into the picture, but its remaining its bus time is 10, or its remaining time is 10 only. So till 40, P3 will be executed and P3 will be over. Okay, P3 is over. Now at 40, there is only one choice. What? That is the P2. Okay, there is no other choice with us. So I have to execute P2. Now till what time it will be executed? See this. So 45, P4 is coming at 45. Na? So till 45, I will execute P2. So 40 to 45, 5 units of time I have executed. So its remaining time is 10. So now at 45, P4 is coming into the picture. Now, but P4 remaining time is 15 and P2 remaining time is 10. So I will say like this, at 45, there are two processes in the system. That means P2 and P4. These are the two processes which are in the system. Okay, P1 and P3 are already over. So now which is having least bus time? P2 is having the least bus time. So obviously P2 will be executed first. Okay, so I will execute P2 till what time? 10. So 55. Till 55, P2 will be executed and then P4 will be executed. Okay, for 15. So 55 plus 15. 55 plus 15, 70. Okay, I hope I have made the point here. Gantt chart is over. Now I think you can easily solve everything. Waiting time of P2 they are going to ask. Okay, so what is the waiting time of P2? P2 waiting time will be what? Turnaround time minus burst time. Turnaround time is process finish time minus process arrival time and then minus burst time. Process finish time. What is the process finish time? P2 finish time is what? 55. At 55, P2 is over. Now arrival time. P2 arrived at what? 15. Burst time of P2 is what? 25. So 55 minus 15, that is 40. 40 minus 25, that is 15. I hope I have made the point clear to everybody. So answer is 15. So 15 is the answer. So P2 has waited for 15 units of time. Okay, so now if you want to check it out, I will show you. Okay, so see this scenario. See, P2 has started at 20. P2 has started at 20, but P2 arrived at 15. So it has waited 5 units of time here itself. P2 has waited 5 units of time here itself. Now till 30 P2 has been executed. Now 30 to 40 P3 was executed. So P2 has waited again. P2 has waited again for how much time? 10 units of time. 40 minus 30, that is 10. So it has waited. Now after that P2 has been executed continuously. Okay, 40 to 45, 45 to 55. P2 has been executed continuously. Now, so see, I am just showing you that 40 to 45 P2 and then 45 to 55 P2. But actually I should say like this. 40 to 55 directly I should say P2 has been executed, but I have shown you 2 times because I have told you that at 45 I have to take a break. I have to take a pause and see which are the processes in the system and which will be executed and so on. Okay, so finally I have shown you like this. Okay, so finally 5 plus 10, that is 15. 15 is my answer. Okay, so same 15 and 15. So I have just confirmed you that why 15 is the answer. Okay, and they can ask you response time also. Response time of P2. What is the response time of P2? See, P2 arrived at 15 and it has started at 20. Process start time minus arrival time. So 5 units of time. So response time of P2 is 5. Okay, but waiting time is 15. So I have told you in the previous class that response time and waiting time are different. But in non-preemptive scheduling algorithm, this is very, very important point. Please try to focus here. In non-preemptive scheduling algorithm, waiting time is equal to response time. No problem at all. Okay, because once the process has started, it will complete. No problem at all. It will be completed perfectly. No problem. But in case of preemptive scheduling, it may be preempted. So that's why waiting time will be greater than or equal to response time. Okay, so see, the response time of P2 was 5. It has arrived at 15 and completed at 20. So response time of P2 was 5, but waiting time is coming to be 15 because it has P2 has not been executed continuously. After till 30 it has been executed and then it has taken a pause because P3 come into the picture, which was having less burst time or less remaining time. So CPU was preempted and given to P3. So since CPU was preempted and given to P3, so P2 has to wait. Okay, so you can think like this. So in preemptive scheduling, you have to, you can say CPU can be snatched from the process. Since CPU can be snatched from the process, so it has to wait. Okay, so you can think like this. If you want a real life example, you can think like this. This is your home, okay, and this is your school or this is your college. If you take a single bus only and you reach your college from your home, you reach your college by via single bus, that is a non-preemptive scheduling. Okay, because once you board the bus, you will never leave the bus and you will directly reach your college. That's it. So whatever you wait at your home, that is your waiting time, and obviously that is your response time also because you have waited at home, or you can say your bus stop. Whatever you have waited at the bus stop, that is your waiting time. Okay, that's it. Because and that is your response time also, because once you board the bus, you will never leave the bus. You will immediately reach the college and then you will leave the bus. That is the non-preemptive scheduling algorithm. But what is the preemptive? This is your home. Okay, so this is your bus stop number 1. You have taken the bus. You cannot reach your college directly from single bus. You have to take multiple buses. So bus stop number 1, you board the bus till bus stop number 2. Now from bus stop number 2, you will board the bus and you will reach bus stop number 3. And then finally you will reach your college. Okay. So waiting time is what? Waiting time is the waiting time at your bus stop number 1, bus stop number 2, bus stop number 3. Sum of all these, that is the waiting time. But response time is what? Response time is the waiting time for the bus stop number 1 only. Okay. So response time means process start time minus arrival time. So when it has started and when it has arrived. Okay, that is the basic difference. So so waiting time at bus stop number 1, that is the response time. But what is the waiting time? Entire waiting time, entire waiting time. So total wait will be what? Total wait will be you are waiting at the bus stop 1, bus stop 2, bus stop 3. That's Okay, so I hope I have made the point clear. So for preemptive scheduling algorithm, waiting time will be greater than or equal to response time. Okay, so I hope I have made the point clear to everybody. Yes, please take snapshot or something. I will jump to the next slide now. Okay, I'm jumping now. So next is the round robin scheduling algorithm. Let me show you something about round robin. What round robin is saying? So in round robin scheduling, time quantum is given, that is 2. So 2 units of time is the time quantum. So process has been finished or not, it hardly matters to me. After every 2 units of time, I will snatch the CPU from the process. So it is just like, you can say, first come first serve only. We have studied FCFS. So FCFS preemptive version. FCFS preemptive version is round robin scheduling. Preemptive version is round robin schedule. RR means round robin. Okay. So why I'm calling it as preemptive? Because I have told you, na, CPU will be snatched. So as soon as you say CPU has been snatched, so immediately it will be preemptive. Okay. So let me show you here. So now here arrival time is not given. So obviously what I will take, I will suppose arrival time is 0 for all the processes. So which process will be started first? Obviously P1 will be started first. So in case of tie, we will take that process which is having least process ID. That is the rule. Okay. So in case of tie, process having least PID is executed first. Okay. So P1 will be obviously executed first. Yes. So 15 is the burst time. Na? So it will be executed till 2 because time quantum was 2. So after 2, CPU will be snatched and given to P2. P2 will be executed till 4. So please try to cut it here itself. So P1 has been executed till 2 time. So remaining time will be 13. Now P2 will be executed for 2 units of time. Remaining time will be 3. Okay. So now CPU will be snatched from P2 and it will be given to P3. So now P3 will be executed till 2 units of time. So its remaining time will be 1. So like this. So now again P1 will be executed. So it's just like a circle. Okay, P1, P2, P3, P1, P2, P3, and so on. So P1 will be executed till 8. So its remaining time will be 11. Now P2 will be executed till 10. Its remaining time will be 1. So now P3 will be executed till what? Its remaining time was 1 only. So obviously it will be executed for 1 unit of time and P3 is over. You will cut it. So now what we will do for so after P3, P1 will be executed for 2 units of time. That means till 13 it will be executed and its remaining time will be 9. So after that, P2 will be executed. P2 remaining time is only 1. So it will be executed for 1 unit of time and P2 is over. So when P2 is over, so only P1 is left here. So obviously P1 will be executed continuously. So if you want me, then I can show you like 14 and then 16 P1. Then no other process in the system. Then again P1 will be executed till 18. No other process in the system. P1 will be executed again till 20 and so on. Okay, so in place of writing like this, I will write it directly. Okay, so 9, since no process is there in the system, only P1 is remaining, 9 unit of time. So 9 plus 4, 23. Yes, so 23. So till 23, so P1 will be over. I hope I have made the point clear. This is all about the basic scenario of round robin scheduling. Okay, yes. So we have made our Gantt chart. Now it's really very easy. Now I can solve each and every question like waiting time, response time, whatever question you want, we can solve very, very easily. Okay, let me show you few questions. Like I say waiting time of P1. Waiting time of P1. What is the waiting time of P1? What is the formula? Turnaround time minus burst time. Turnaround time, process finish time minus process arrival time and then minus burst time. Finish time. So P1 finishes at 23. Arrival time. Obviously it was 0. Burst time. Burst time of P1 was 15. So 23 minus 15, it comes out to be what? 8. So 8 unit of time. So I will say it has, you can say waiting time is 8. So if you want to prove it, I can easily prove it from the Gantt chart. So at time 0, P1 came and it has started immediately. So obviously there is no waiting here. Okay, so now you can imagine bus stop number 1. So from home, you just come out and you will immediately find the bus at your bus stop. and you board the bus. You will be very excited. Okay, I have bought the bus and so on. So immediately P1 has bought the bus. It has arrived and immediately it has got the bus. So obviously no waiting at all. At bus stop number 1, no waiting. So at time 2, till time 2, P1 was executed. Okay, so now from 2 to 6, P1 was not executed. So 4 unit of time it has waited. So till 8 it has been executed. From 8 till 11 it has waited. So what is the time? 3. Okay, 8, 11 minus 8, that is 3. Now P1 was executed till 13. From 13 to 14 again P1 was not executed. So 4 plus 3 plus 1. So obviously it is coming to be 8. So 8 is the waiting time of P1. So I hope I have made the point clear to everybody. Waiting time of P1 is 8. Similarly, you can find waiting time of any process. Okay, and let me find the response time. Okay, response time is very, very important because I have to tell you a very important point for round robin scheduling. See the response time. Response time of P1. Response time of P1 is 0 because at time 0 it has came into the picture and immediately it has started. Now response time of P2 is what? It has started at 2. So response time of P2 is 2 because it came at arrive 0. It come at time 0 and it started at time 2. So 2 units of time it has waited for the first bus. For first bus, it has to wait for 2 units of time. So hence, response time is 2. Okay, G. So response time of P3. P3 has started at 4, but it has arrived at time 0. So obviously it has waited 4. Okay. So response time of P1 is 0, P2 is 2, P3 is 4. So now you all may be wondering that why, after all, why we are using round robin? So why after time 2 I have snatched the CPU and given to P2? Now after again I have executed P2 for only 2 units of time and then again I have snatched the CPU and given to P3 and so on. So why I am snatching CPU and given to other processes? And even though we were having entire processes in our system, P1, P2, P3 all were present in the system at the same time at time 0. But still I have snatched the CPU and given to the other processes. Why we are doing all these kinds of things? We are doing this so that response time will become minimum. Okay, response to reduce the response time, round robin scheduling was developed. Okay, round robin scheduling was just developed to reduce the response time only, because now obviously response time will be very, very less. So P1 has immediately started, then after 2 CPU was given to P2. So obviously response time of P2 will be only 2. If P1 was executed completely after 15, I give CPU to P2, so it has to wait till 15. So response time of P2 will be 15 and I do not want it. Okay, so I want response time to be really minimum. That's why I'm using round robin scheduling algorithm. So that is the biggest advantage of round robin scheduling. Anyhow, I have written these points after a few slides. So please do not, if you want, you can note it down. Otherwise, I will show you after a few slides. You will get these important points. Okay. So response time will be minimum at round robin scheduling. Okay, and everything now you can find it out. Turnaround time of P2, waiting time of P3, and so on. You can find each and everything. I'm not going into all these details. Okay, because our main aim is to prepare the Gantt chart. Once our Gantt chart is prepared, we can easily find all answers to all such questions and all things. Okay. So average response time, if we want to find average response time, will be 0 plus 2 plus 4 divided by 3. It comes out to be 2 only. Okay, so on an average, every process has every process has to response time of 2 only. Okay, that is the biggest advantage. That is the minimum. Okay, let me jump to the next slide now. Please take snapshot. Okay, so now arrival time is given. Okay, same question for round robin I am doing, but arrival time is given to us. Okay, arrival time is 0, 2, 4, and 5, and so on. Arrival time is given, and bus time is given, and PID is given. Now, if arrival time was not given, I have just made a cycle P1, P2, P3, P1, P2, P3, and so on. I have done like this. I have made a cycle P1, P2, P3, then P1, P2, P3, and so on. But if arrival time is given to us, I cannot make such a cycle. Why? Please have a careful look here. Time quantum is 3. Time quantum 3 means after every 3 units of time, CPU will be snatched from the process. So at time 0, only one choice. That means P1. I'm preparing the Gantt chart. Okay. At time 0, there is only one choice. That is P1. So till time 3, P1 will be executed. Now till time 3, what are the choices which I am having? Okay, so side by side, I will make a queue so that you get more clarity. At time 0, there was only one process in the queue, that was P1. Okay, Q means, I think you already know, Q means FIFO, first in, first out. So whatever process will arrive first, that will be that will come out of the queue first. Okay, so it's just like a, I think you already know, na? Queue means what? There is a person who is giving ticket counter. You are there is this person is giving tickets to everybody. So this person is at the ticket counter. Okay, and we have a queue of persons. So many persons are in the queue. So who will get the ticket first? Obviously, the process which is, or the person which is at the head of the queue. Okay, or you can say the process, or you can, the person which is at the start, that will be given ticket first, na? And once he has got the ticket, he will come out of the queue, and then other process will be given the ticket, and so on. So it's just like queue. I think you already know. It's just like common sense. Okay. So in the queue, only P1 was there at time 0. There was no choice at all. So obviously from 0 to 3, P1 has been executed, and I will cut its burst time to 5 because 3 times it has been executed. Now at time 3, which processes are there? You have to think. So at time 3, see, I will say from 0 to 3, P1 was executed, and when P1 was executing, there was no process in the queue, na, because it is the waiting queue. Okay, or you can think, please do not confuse with the waiting queue and all. Do not confuse it with the state of the process, new state, ready state, waiting state, and so on. I have told you, na. So do not think waiting queue means the waiting state and all. Please, it is not the case. Okay, so I will say you can think of ready queue. More precisely, we should say ready queue. So in the ready queue, there was only one process P1 at time 0, and it has been started at the CPU. Okay, so obviously P1 is at CPU, so now there is no process in the queue. But but at time 2, P2 come into the picture. So at time 2, P2 is in the queue. Okay, now after time 3, see carefully, after time 3, P1 from the CPU, it will come and it will be there in the queue. So at what place it will be placed? Obviously after P2 it will be placed. Now after P2 it will be placed. Okay, so which process is at the head of the queue? P2 is at the head of the queue, because in the queue P2 arrives at time 2, but in the queue P1 arrives at time 3. So obviously P1 is arriving after P2, so head of the queue will be P2. So now obviously head of the queue will be executed first, so P2 will be executed first. So till time 6, P2 will be executed. So burst time will be burst time remaining will be 6. Okay, because 9 minus 3 is 6. Okay, 3 units of time. Time quantum is 3 now, so 3 units of time P2 has been executed. Now see at 6, what is the scenario of the queue? At time 6, what is the scenario of the queue? So see this. So now at 3, at time 3, queue was like this, P2 and P1. Now P2 has gone to the CPU. So head of the queue was P1. See carefully, you will make a very big mistake here. Head of the queue is P1. If you are not getting it, please rewind the video, watch it again. I will not waste time here. Okay, because video will be unnecessary big here. Length will increase. So batteries, it's online. So you can rewind the video and watch it again if you have any doubt. Okay, now please try to concentrate. So now at time 3, P2 was at head of the queue. So P2 come to the CPU because it was executed, and head of the queue was P1. At 3, head of the queue was P1. Now at time 4, P3 comes. So it will be there in the queue. Now at time 5, P4 came. So P4 will be here. Okay, and so at time 5, P4 came. So this is the queue. Now at time 6, P2 will come and it will be attached here. Okay, yes, so finally at 6 time, which process is at the head of the queue? P1 is at the head of the queue. So P1 will be executed till what time? 9, because 3 units of time. Time quantum is 3 now, so 3 units of time it will be executed. So its remaining time will be 2. Now after P1, so at 9, so P1, so at 9, what will be the queue like? So P1 has been executed here now. So P3 will be at the head of the queue, P4, P2, and at 9, P1 will come and it will be attached here. Now at 9, this scenario we are having. So which is at the head of the queue? P3 is at the head of the queue. So P3 will be executed. So P3 will be executed till 12. So P3 remaining time will be what? I think you have got it. It will be 9. Okay. So now see carefully. Actually, I can say from here itself. Okay, but I have shown you just one more step so that you get more clarity. Now, point is very beautiful. You have to concentrate here, because if you are able to concentrate here, you got the point. Then you will be easily able to solve each and every round robin question. See, in the previous question, what was the scenario? If I want to make a queue, I will say at time 0 only 3 processes were there in the queue. All the 3 processes were there in the queue at time 0 only. So there was no problem. I just made the cycle P1, P2, P3, P1, P2, P3, and so on. Same is the case here. Now at time 6, all the processes were there in the queue. P1, P2, P3, P4, all the processes were there in the queue. So now no need to worry. Okay, I have just shown you one more step. So that you get more clarity. But no need to do all kind of things. No need to waste any time here. At time 6, you will say like this. At time 6, this is at time 0, at time 3, at time 6, at time 9. So at time 6, all the processes are now in the queue. So now you just made a cycle P1, P3, P4, P2, P1, P3, P4, P2. That's it. Everything will be over. So now P1 I have executed. Now P3. Then blindly you will say P4 and then P2. Then P1, P3, P4, P2, and so on. Okay, so no need to see the queue at time 9, no need to see queue at time 12, and so on. It is just wastage of time. Okay, I have linked with the previous question. So in the previous question, at time 0 only, all the processes were there in the queue. So I have made a cycle. So here now at time 6, all the processes are there in the queue. So now I will make the cycle. No problem at all. So P1, P3, P4, P2, P1, P3, P4, P2, and so on. Okay. So anyhow, P1 was executed, P3 was executed, okay, and then P4 will be executed. So P4 will be executed for how much time? 3 time unit, 15. So here 12 will be remaining. Okay, so now P2 will be executed. P2 remaining time is 6 now, so it will be executed till 18, and remaining time will be 3. Now P1 will be executed. P1 will be executed for 2 units of time only, because its remaining time was 2. So P1 you will cut it. So P1 will be executed till 20. Okay. Yes. So now you will remove P1. So now you will make a cycle of P3, P4, P2, P3, P4, P2, and so on. Okay. So P1 you will cut out. So now P3 will be executed for 3 unit of time. Remaining time will be 6. So 23. Now P4 will be executed for how much time? 3 units of time, 26. Now P2 will be executed for 29. Okay, P2 remaining time was 3. So now P2 is also over. So now you forget about P2 also. Okay, so now from C here, P1 is over, P2 is over. So now P3, P4, P3, P4. You will keep on doing like this. P3, P4, P3, P4, and so on. So let me check it out. So P3 remaining time is what? 6, na? So it will be executed 3 units of time. So 22. Then P4 will be executed 3 units of time. So it will be 25. Then P3 will be executed for 3 units of time, 28. Okay, and P3 will over. Okay, and then P4 for 6 units of time, na? So it will be what? 34. Directly I have written, because only one process was remaining. That's why I have written directly. Okay, so please try to focus here. So that is the basic scenario. Okay, anyway, I need not solve this calculations. You can do all of your own. Okay, that is the basic scenario. So I hope I have made the point clear to everybody. Okay, so that's it. So this is all about the basic scenario of your round robin scheduling. So if you have got this numerical, now I think you have got everything. You can solve each and every kind of question now. Okay, so I think I should not waste time here asking questions like waiting time of P2. It's your homework. You can do it yourself. Waiting time of P2, you can do it. Okay, turnaround time of P3, you can find out. Okay, and then average response time, you will find out, and so on. All these questions are now homework, because you just have to apply formula and get the answer. Once Gantt chart has been prepared, everything is over. Please try to grasp this question properly. If you have any doubt, you can ask in the comment section, but please try to focus here. If you have any doubt, you please try to rewind the video and watch it again and again. Okay, the more you rewind it, the more you will get it. Okay, that is the basic scenario. Okay, and it's my humble request, please try to solve this question on your own. Okay, and match the answer with me. Okay, yes, so that's it. So this is all about your round robin scheduling. Okay, yes, so yes, please take snapshot. So you have to see advantage of round robin, response time is minimum. I have told you many times and I have proved it also. Response time will be minimum in round robin scheduling. Okay, now. Okay, so that's it. So next is priority scheduling. We will study that in the next lecture. Okay, thank you so much. Bye-bye.